Welcome to the Commonwealth Club World Affairs. I'm George Hammond, Chair of the Humanities Forum, which organized today's event. We have today Jessica Riskin from Stanford University and her book, The Power of Life. It's one of those very unusual books to me that takes a look back at the history of science and says, you know what, there was something in the history of science that was better than the path that we took, or at least more interesting in some ways, and that there's some stuff that we left behind we should not have left behind. Always a difficult argument to pull off, and she pulled it off extremely well. So today we have Jessica Riskin from Stanford on The Power of Life. She's going to tell us about the French naturalist Lamarck and what happened to his ideas. Jessica.
First of all, I want to thank George Hammond and Humanities West and all the folks at Humanities West. It's really, I cannot imagine a more beautiful place to get to talk about my book. And also my lovely friends who are here to hear about it. So I'm imagining that at least some of you are thinking about giraffes, because that seems to be the main thing that people associate with Lamarck. If they have any association with Lamarck, usually it's giraffes. And I'm going to come to giraffes in a moment. But first, I wonder if anyone here knew that it was Lamarck who coined the word biology in 1802. So you have it there on the left side. Oh, sorry, I'm going to use this screen, actually. On the left side, you have it in handwriting, and on the right side in print for the first time in 1802. This is in his private notebook. He comes up with this idea for biology, considerations on the nature and faculties and development and origin of living bodies. And he coined that word in order to name a science that he thought should exist that did not yet exist, which was a science of all and only living things. So up until this point, there were larger sciences like natural history, which covered a lot more than living things, rocks and rivers and mountains and stuff like that. And there were, as well as living things, and then there were smaller sciences like botany or zoology that covered subsets of living things. But he thought that there should be a science of all and only living things, a science of life. And so he coined that word to name it. And he also developed the first modern theory of what we now call evolution, although he never used that word. He just referred to change in living forms from generation to generation. So Lamarck lived and worked in the Botanical Garden in central Paris during the French Revolution and under Napoleon. So as you can imagine, he had a very stormy life with all the elements of, sort of Shakespearean elements of tragedy and comedy and triumph and isolation. Starting in childhood, he was the 11th child and 4th son of a military family from Picardy in northern France. And what that meant was that by the time they got to him, they had exhausted all of their money launching his older brother's military careers. And so they packed him off so on the right you see the Botanical Garden where he lived and worked, and that's our friend Lamarck. And now I'll show you where they sent him. They packed him off when he was 11 to a seminary to study for the priesthood. But he was really not enthusiastic about this plan. And when his father died, a few years later, his first words, according to his own son, Auguste, his first words were, "So I won't be a priest." And he flung off the seminarian's collar, and he took one of his mother's old horses, and he went galloping off to join a regiment that was fighting in the 7 Years' War in Central Europe. So he arrived for a battle, which is not actually that battle, but I want to show you an image of sort of approximate battle. And he remained in the military for a few years until he had to leave because of a neck injury, possibly from horsing around with his fellow soldiers. This is according to Georges Cuvier, the paleontologist, who was Lamarck's arch nemesis, and also, funny story, which I'll come to, had the task of writing Lamarck's eulogy. And in the eulogy, I put eulogy in quotes, he said that he sort of nastily insinuated that Lamarck had been horsing around with some fellow soldiers, one of whom had tried to lift him by the head, and he'd gotten a neck injury. But whatever it was, he had to leave. But in the meantime, what had happened during the time that he was a soldier was that he had his regiment had been garrisoned in Provence, and he had fallen in love with the wildflowers there, and he had traded some of his music notebooks because he played the viola da gamba, which is kind of like a cello, and he had a lifelong love of music. He played for his whole life. but he took some of his precious music notebooks and he traded them to his brother in exchange for this botanical handbook on the right side. And he took that to go out and collect plants and try to identify them. He got a local pharmacist to help him. And so when he had to leave the army, he decided he'd go to Paris and study botany. And that was his entrance into the field that he would later redefine under the name biology. So now we're coming to giraffes. Somehow, as I say, the giraffe somehow became the emblematic animal of Lamarckism, even though on the slide here, on the left side of the slide, is basically everything he had to say about giraffes. In all of his voluminous writing, he wrote lots and lots of books, but that's basically it on giraffes. But it is a very striking example. So he used the giraffe, among other examples, to represent one of his main ideas, which was that animals could transform their bodies by their behaviors, such as by stretching its neck to reach high up leaves in the trees. The giraffe could lengthen its neck just infinitesimally, but then that would be inherited, and it would be accumulate over thousands of generations, leading to the long neck of the giraffe. That claim provoked what must surely be one of the longest-lived controversies in the history of science, because over 200 years later, the idea that living organisms might transform themselves heritably by their own agency remains a very controversial kind of hot-button question in evolutionary biology. So the book follows that controversy. At first, the reason why Lamarck's theory caused so much controversy was that he was really usurping God's monopoly on creation. So according to his theory, living organisms originated in spontaneous generation, which happened when natural forces like electricity or heat acted on inanimate matter, and they would cause the spontaneous generation of single-celled organisms like protozoa, which he called monads, and algae. So just the very simplest forms of life. And then once it was spontaneously generated, living matter, he thought, had a tendency to complexify itself by a force that he called the pouvoir de la vie, or the power of life. So that's where the title of the book comes from. It's Lamarck's own phrase for the complexifying, what he took to be a complexifying tendency of organic matter. And let me just say, this was like other forces in contemporary physics, in contemporary science. You know, there was people were studying magnetism and electricity and gravity, and all of these were forces that caused matter to tend in various ways, right? And so he thought that he was adding one that was specific to living matter, which is this force of complexification. And as organisms became more complex, I can try out my pointer. Does that work? As organisms became more complex, so the right side of the slide here shows this kind of momentous first chart of evolution, with animals becoming more and more complex, interestingly from top to bottom, rather than, we're more used to seeing it as an ascent rather than a descent. But Charles Darwin actually, when he published his version of a theory of evolution, at first he called it descent with modification, descent. So as organisms become more complex, as you see in the chart, another cause of transformation comes into play, which is responsiveness to the environment. And in lower organisms, this responsiveness is takes very primitive forms. But from the level of birds and mammals, Lamarck says, organisms can perform acts of will, forming habits and ways of life in response to their circumstances, like stretching their necks or other habits. Now, in addition to creating and recreating themselves, Lamarck also said that living organisms composed the inanimate world. All minerals, by which he meant compound matter, inanimate compound matter, he said came from the actions of living beings. And as a botanist, he gave the pivotal role in this process to plants, because plants, he said, could produce themselves just from sunlight, air, and water, kind of magically. All they need is sunlight, air, and water. And he has these various experiments that you can perform to prove this. So a narcissus bulb, if you raise it just in water, you weigh the bulb, and then you raise it just in water in the window, It'll grow a whole plant that'll weigh much more than that original bulb, but it had no access to anything except sunlight, air, and water. Same thing with pea plants raised in cotton wool soaked in water. He has a very funny one, which I think of as, he has a very funny experiment where you carve a hollow in the side of a turnip, you suspend it by its root in the window, you make sure that the hollow in the turnip has water in it. So I think of it as being sort of like Harry Houdini turnip. It's nothing up its sleeves. It can't do anything but just be there, hanging there, and yet it produces a whole plant. Then animals can take plants or other animals and turn them into more elaborate compounds, and so they share this defining ability of living beings, which is to build, compose, create. To live, according to Lamarck, is to create and compose. Now, luckily for the history of biology, Lamarck was not allowed to remain a botanist, but he had to remake himself at the age of 50 into a zoologist. And that's because during the French Revolution, with the reorganization of the garden, the Royal Botanical Garden, transforming it into the Republican National Botanical Garden and National Museum of Natural History, the committee in charge of this reorganization assigned Lamarck to the lowliest of 3 positions in zoology, not botany. They assigned him to the professorship of insects and worms, which I think is an absolutely magnificent title. He became professor of insects and worms. He did have a marvelous shell collection, and that was sort of his only qualification for this. But mollusks, actually, according to this older Linnaean classification, mollusks counted as worms. So that was I guess, an excuse for him to take this job. He was now a widower with 6 children. He would remarry and have 2 more children. And the job came with lodgings on the 2nd floor of this beautiful 15th century mansion, which is just inside the gates of the garden. So that was a perk of the job. And I went and looked in there with a friend last summer. It's now lots of little offices, like a warren of little offices, and it's not open to the public, but we just kind of lingered outside the door looking hopeful until someone came and let us in, and we said we really wanted to see the 2nd floor, so they let us come up. Now, later on, Lamarck told his students that he'd been disappointed at first if he couldn't study plants like he wanted to. At least, why couldn't he have studied charismatic megafauna like lions and things? But then he had a couple thoughts. One of them is that his area of insects and worms covered 9/10 of the animal world, so that's obviously important. And the other one is that he thought that the simplest animals might reveal the essence of animal life, the foundation of animal life. So, contemplating his insects and his worms with this gleam of hope, he first of all renamed them the invertebrates, so he coined that term also, inventing a new taxonomic category. And he said, the invertebrates show us the inconceivable limit of animalization, those beings barely endowed with animality with whom nature perhaps began. And this essence of animality, he thought, was the power of generation. The very simplest creatures have the most extraordinary powers of generation. For instance, the Swiss naturalist Tremblay had shown this with experiments on the polyp or freshwater hydra. If you chop them up in pieces, each piece will grow a whole new animal. So that's an extraordinary power of generation. Other invertebrates could do incredible things in terms of generation. Also, insects metamorphose, crustaceans grow new legs, starfish new rays, snails a new head. Lamarck said the tiniest and simplest animals have a frightening fecundity such that it seems as if matter animalizes itself from every direction. And he marveled at the minuscule coral polyps, along with shellfish, can produce mountain chains and whole islands and completely transform coastlines. So Lamarck came to understand life as this kind of creative action in the face of all of nature's forces of destruction. He was a romantic with a capital R, meaning that he lived right in the Romantic period, and when he was reading and writing and working, this was the kind of cultural world around him of romantic poetry and philosophy and so on. So his science of life had a tragic as well as a heroic aspect. Ultimately, all living beings must succumb to the forces of nature and relinquish everything that they have made in a lifetime. This idea of living beings as tragic heroes, again, as I say, it sounds romantic, as indeed it was, but 2 centuries later, the role of organisms in the formation of minerals is a subject of interest in geology. So the images on the slide are from a mineral physicist named Robert Hazen. I've borrowed his images, and they illustrate the great oxidation event, a sharp increase in atmospheric oxygen that took place apparently a little over 2 billion years ago when emerging microorganisms seeded the atmosphere with oxygen. And this was apparently the crucial turning point in the proliferation of diverse kinds of minerals on Earth. So Robert Hazen, this geologist, mineral physicist on the slide, has said the origin of life depends on minerals, but the origin of minerals depends upon life. So Lamarck's idea of living beings as the sources of the inanimate world is current in science. The invertebrates became the basis of his theory that living organisms held a monopoly on creative agency. He wrote that religion was all very well for the good man who can persuade himself of it, but he said it's absolutely foreign to my subject. Souls are not physically observable, whereas this dynamic, creative activity of living beings is everywhere. You see it everywhere. He was also interested in the collaborative aspect of this work of building the world and fending off destruction. One spring day in 1798, he and his family were at a country house outside Paris, and he noticed a swallow's nest in one of the windows. And soon after that, he saw that a local child had destroyed the nest just when the female was about to lay her eggs. And immediately he noticed that 10 or 12 birds had gathered around the wreckage, and they were very agitated and very noisy, and he assumed they were fighting. And then he realized that it was exactly the opposite. They were organizing themselves to rebuild the nest. So he watched in amazement as some birds stayed by the construction site, others came and went fetching twigs and things. And he said that it usually takes 8 to 12 days for swallows to build a nest, but these finished by the next morning. They managed to finish together by the next morning. So he had lots of examples of animals' continual self-transformation. He began with cases of a diminished use of a part that made it weaken or disappear. If you don't use it, you lose it. So the vestigial teeth of whales and birds and anteaters, which can swallow their food without chewing. The vestigial eyes of moles that live in the dark. The vestigial leg bone structures of snakes that slither on the ground, so legs would be an encumbrance, actually, to them. And then there's the opposite process of the increased use of a part that develops and shapes it, so the webbed feet of water birds from pushing against the water, the hooked talons of eagles from clasping at branches. And my favorite of his examples is the shorebird, which he says, the shorebirds that have these long, skinny legs, they don't like the water, and so but they have to wade out in order to get their prey. And so they sink into the mud. And as they do that, they stretch their legs in disgust, and they try to stay as far up out of the water as they can, and they crane their necks, and that's how they get the skinny legs and necks. And the proof of this, he says, is that swans and geese have short legs, but long necks. And the reason for that is that they're perfectly happy in the water, so they don't stretch their legs, but they still crane their necks in order to get the plants underwater. A seal arrived in the menagerie of the Natural History Museum in June of 1809, just as Lamarck was finishing his magnum opus, the Zoological Philosophy, and he sat and watched it with fascination and took notes. He noticed that, first of all, it had an obvious kinship with land mammals, that confirmed his idea that all mammals, and in fact all life, originated in the water. He also noticed that it used its hind limbs as a paddle, but the legs had not fully joined together to become a fin, and that's because he saw that the seal still also used them for seizing prey. So in other words, the distinctive combination of uses that the seal used its hind limbs for had produced this structure that could function either like a paddle or like a hand. Now, Lamarck's idea of self-making and world-making living beings made him some powerful enemies. In particular, the paleontologist Georges Cuvier. And this is where we cue the Darth Vader theme. I hear the Darth Vader theme because he's the villain of the story. He was really Lamarck's nemesis. He was a member of Napoleon's scientific inner circle, very sort of powerful position under Napoleon. He was a devout Lutheran who categorically rejected the idea of evolution. He said animals' habits and behaviors followed from their structures. They behaved as they were designed to behave, whereas Lamarck was proposing the exact opposite, that the structures followed from the behaviors. Seemed to Cuvier exactly upside down and backwards. He did believe in extinctions, but he assumed that the fossil, in fact, he did very important work establishing that there were extinct animals. But he assumed that the fossils of extinct creatures reflected catastrophes like floods and fires that eliminated all the living beings at a given time to be replaced by newly created ones. So this supported the doctrine of special creation, that God created each species for its place in nature. And Cuvier's science was perfectly suited to Napoleon's purposes because it was a scientific doctrine of revolutionary change, but at the same time, if you think about it, it was profoundly conservative. Each change was imposed from outside rather than rising up from inside. And each time it was a return to the same ultimate authority, guaranteed not by the church now, but by Napoleon's scientific experts. So that was perfect for Napoleon. Lamarck challenged that view, and so it's no surprise that Napoleon hated Lamarck and tried to undermine him at every turn. So the image on the slide illustrates a story told by François Arago, who's on the right side. He's an astronomer. He was an astronomer, and when he was a young man of 23, he found himself standing in a chilly salon of the Tuileries Palace in November of 1809, very cold day. The members of the National Institute were waiting for the emperor in order to present him their new works. And standing near young Arago was Lamarck, who was then 65 years old and quite frail, although he would live another 2 decades, but in frail health, holding a copy of his zoological philosophy. Napoleon at last came into the room and went stalking up to Arago as though he were a new conscript, fixed him with a stare and barked at him, "You're very young, what's your name?" Before he could answer, his neighbor on the right, eager to be noticed by the emperor, says, "His name is Arago." And Napoleon says, "What science do you cultivate?" And now his left-hand neighbor, not to be outdone, says, "Astronomy, he's an astronomer." So Arago is sort of in this confusion of everyone trying to answer for him. Meanwhile, the emperor turns to Lamarck, who holds out his zoological philosophy, and Napoleon snatches it from his hands, growling at him, "I'm taking this only out of consideration for your white hair." And he, without looking at it, thrusts it into the hands of an aide, reducing Lamarck to tears of humiliation as he tries to explain what's in the book. But had Napoleon known what was in the book, he would surely have liked it even less, because it really was not the sort of science he appreciated. Rather than consolidating power, Lamarck's theory distributed it all throughout the living world. Napoleon, of course, was a consolidator, not a distributor of power. Cuvier was the victor who wrote the history, as I've mentioned, quite literally. As director of the National Institute, he wrote Lamarck's official eulogy, which holds the distinction of being probably the meanest and nastiest eulogy ever written, in which he describes Lamarck's theory as poetry rather than science. And that really set the tone for assessments of Lamarck's ideas for a very long time to come. Following Cuvier, a succession of influential and powerful people ridiculed Lamarck's science. And I think, this had to do with the fact that it emerged in the midst of the French Revolution. It replaced God with creative living beings, mortal beings. It really smelled to contemporaries of radicalism and atheism and revolution and regicide, all kinds of dangerous things. And this promised trouble not only for Lamarck and Lamarckism, but for evolutionary theory more generally, especially in the conservative and reactionary turns of the later 19th century. So Charles Darwin really struggled over his relations both to Lamarck and to his own grandfather, Erasmus Darwin, who's the jolly guy on the left side of the slide, Erasmus Darwin. Erasmus Darwin had been a doctor and a naturalist and a romantic poet and an admirer of the French revolutionaries, and also, like Lamarck, he had suggested that living forms might transform from generation to generation, sometimes in verse in his poems. The slide, so Charles Darwin struggled over, because he was working very closely with Erasmus Darwin's ideas, and also especially, even more so, with Lamarck's ideas, but he wrestled with it. And so in a page from his 1837 notebook, where he's just thinking his way into his own theory of evolution, you can see him wrestling. So he's jotting things down and then crossing them out and tearing out the pages. And the crossed out line here says, "Man is derived from monad, each fresh," and that's crossed out. And monad, of course, was Lamarck's word for the simplest spontaneously generated living organisms. But I really want to emphasize that Darwin did retain very important features of Lamarck's theory, various forms of living agency within the evolving organisms, including what Darwin called the inherited effects of use and disuse. And this is a really important point, because people generally represent Darwin and Lamarck as opposites and say that Darwin didn't believe in the inherited effects of use and disuse, but it's in everything he ever wrote. He really did believe in it. He was a Lamarckian in that sense. And it was really his followers after he died, around the turn of the 20th century, who eradicated all traces of Lamarckism from their neo-Darwinist theory. So neo-Darwinist theory is very different from Darwinist theory. And the leading figure in this movement to establish a new version of Darwinism was the German evolutionary biologist August Weismann. You see him here on the slide. Weismann made a sharp distinction between body cells and germ cells, or reproductive cells. And he said that no changes taking place in the body cells could ever be transmitted into the germ cells in order to be inherited and passed on. So this is the so-called Weismann barrier, eliminating the possibility of inheritance of acquired characteristics. And Weismann, in order to demonstrate this, he performed a series of rather cruel experiments on mice, in which he chopped off, you may have heard of these experiments actually, this is something that many people also associate with Lamarck. He chopped off the tails of these mice, and then he bred them and showed that their offspring had perfectly ordinary tails. And then he chopped off the offspring's tails, and he did this for several generations. Now, Weismann himself acknowledged that this had no real bearing on Lamarck's theory, because neither Lamarck nor Darwin had ever said that amputations would be inherited. They had said that internally generated changes would be inherited, which is very different. And Weismann knew that, but he said, well, it'll defeat the popular belief in inheritance of acquired characteristics. And it is rhetorically extremely powerful still to this day. As you see, these are images from current online biology textbooks showing the disproof of Lamarck by Weismann with these experiments. The Weismann barrier became the core principle of neo-Darwinism and Francis Crick later restated it as the central dogma of molecular biology. So the central dogma, those are his words. The central dogma of molecular biology is that there's no reverse transcription. So transcription goes from DNA to RNA to protein and never from protein to RNA to DNA, which means that there can be no inheritance of acquired characteristics. The exclusion of Lamarckian inheritance was the rallying point for neo-Darwinism, the utter passivity of the evolving organism. And this was really an extremist position, I think, to insist on the absolute passivity of the organism. So it's an extremist position scientifically. It also, I think, has not been, denying the agency of living beings has not been a purely intellectual or scientific mistake. For one thing, I was surprised to discover the extent to which basically all the neo-Darwinists of the early through the middle decades of the 20th century were adamant eugenicists, fervent eugenicists, and, you know, almost without exception, all of them. And I've come to think that there's a kind of logic to it. There's a eugenic logic built in, I think, to the idea that living beings, including human beings, are the passive objects of genetic programming and outside forces. And then the idea of the fundamental passivity of organisms, I think, has helped to inform 2 centuries of environmental destruction, allowing people to regard the living world as raw material to manipulate and exploit and arrange to their convenience and so on. Lamarck witnessed the Industrial Revolution firsthand, of course. There he was, but he also traveled in Central Europe for a time and went down in mines and visited industrial sites. And he, in his last work, he warned about environmental destruction. He pointed out deforestation and its consequences. And he said that people seemed to be selfish and short-sighted. They went on waging wars and plundering nature for riches and annihilating their own means of conservation. And, you know, this is his last work, written when he was blind and very elderly and very unwell, with the help of his daughter. And he has this very despairing passage in there in which he says, "It looks as if man were destined to exterminate himself after making the globe uninhabitable." So he seems to be right about this to a degree, but let's hope not entirely right about it. So I want to end on a note of optimism. I think that Lamarck's central idea of the agency of organisms has been making a comeback in various areas in various ways. One example is the study of epigenetic inheritance, which is the study of structures outside of the DNA that affect gene expression, and these structures can be inherited, can change in an individual lifetime, and those changes can be inherited in the next generation and can therefore play a role in evolution. And so it's a kind of inheritance of acquired characteristics. And I've been involved in a study of epigenetic inheritance in giraffes. Actually, Lamarck's emblematic animal. Being a historian, this is my first involvement in a scientific experiment, but I managed to persuade some nice biologists to carry out this, and the Giraffe Conservation Foundation in Namibia, and we've been doing this experiment. And epigenetic inheritance is not the only area in current biology that threatens the neo-Darwinian insistence on the evolutionary passivity of organisms. So on the slide, you see Peter and Rosemary Grant, who have studied Darwin's finches for decades, and they've shown that behavior has led evolution in this case, that behavioral isolation of populations precedes genetic isolation. Another example of this is a woman researcher at Yale, Martha Munoz, who works on lizards that live in the Dominican Republic that have moved from sea level up to 3,000 meters, where it's much, much colder. And again, she shows that their behavior has led natural selection and channeled it in certain directions. So as the theoretical biologist Mary Jane West Eberhard has put it, genes are followers, not leaders in evolution. So this is, the study of behavior, the role of behavior, I think, in evolution is another example. The unified evolutionary synthesis, which I guess is on the right side, and the extended evolutionary synthesis on the left side, these are movements in biology that are currently, people in these movements are working to incorporate developmental and ecological and behavioral and even cultural elements into the evolutionary picture, looking at the hunting practices of populations of whales and how they hand these on to their offspring and their offspring's offspring. And the people in these movements often invoke Lamarck. You can see that on the right side, actually, that you have the giraffes. So I'll just end with, I think that Napoleon would be very annoyed. Thanks.
The way they were with Newton. I mean, Newton, has numerology with the Bible, and he had all these other ideas that nobody has ever paid any attention to, but they took the ideas that he liked and said, he's a great, contributor to science.
Yeah.
In this case, Lamarck, you can list real quickly, maybe not that quickly, all the ideas he had that are part of our science,
Yeah.
You've mentioned quite a few in your lecture, but he contributed, like invertebrates. He contributed. I thought it was interesting, your nice little interlude about clouds. He even was the first one to call funnel clouds, right?
Yeah. I'm glad you bring the clouds in. We'll talk, if we can come back to the clouds.
Yeah, go right ahead.
No, that's a fantastic question. I mean, Newton was extremely heterodox in his religious beliefs.
Mm-hmm.
He was, he was not a good Anglican. He had all kinds of, unorthodox beliefs. But he did believe in a divine creator to whom he assigned all causal power. Mm-hmm. So famously, Newton said, "Hypothesis non fingo, I will frame no hypotheses," meaning that he would describe gravity mathematically, but if people asked him what causes masses to attract one another, I will frame no hypotheses, and ultimately it's the will of God. Mm-hmm. And so I think that Newton, in a sense, was sort of the opposite of Lamarck. Lamarck was doing something maybe even more radical. He was insisting that it's living beings mm-hmm. that have, that are the only creative forces in nature. Only living beings. And so I think in a sense, he was more threatening. I mean, of course, Newton is they're living in different periods, mm-hmm. and in Lamarck's period, and especially kind of later into the 19th century, the association with the French Revolution and so forth. He seems politically dangerous, I think, in a way that Newton didn't, mm-hmm. And theologically dangerous in a way that Newton didn't. But then the other thing I want to say, though, is that he did. It's a complicated story because he did ultimately spend his whole career in this extraordinary botanical garden, receiving specimens from all over the French Empire in this place of extreme, good fortune for a naturalist. And he was a member of the National Institute and so on. So he did get to kind of retain those advantages. But at the same time, he was continually embattled and embroiled and much poorer than his colleagues. And, famously when he died, there was so little money that he was buried in a pauper's mass grave in the Montparnasse Cemetery, which was emptied every 5 years into the Paris catacombs. So there's no there's no gravesite or anything. So I think it's a kind of complicated story about Lamarck. But just to summarize and answer to your question, I think he in a sense, his idea was more radical than Newton's. Newton retained an all-powerful creator.
Mm-hmm. All right, well, we'll get back to that in a second, but there's a couple of other holes that your book filled in for me. One was literary. The Frankenstein myth that you could create this thing by shocks of electricity.
Yeah.
That's basically the idea that they were all arguing about at the time, that this is how life probably got started.
Yeah. And not coincidentally, because when Mary Shelley, she was, what was she, maybe 19? And she was in a ghost story or ghost story writing little competition with some friends, Byron and Shelley. And they had been talking about Erasmus Darwin's ideas about spontaneous generation and about other kind of speculations that electricity might play a role in spontaneous generation. And so those ideas coming out of kind of late 18th to early 19th century natural sciences were what she was thinking of when she had her dream that Frankenstein grew out of.
It was also interesting that Goethe was interested in Lamarck's stuff because he was also a capital R romantic of the time, and so it was kind of like the scientific poets against the not so scientific poets. I mean, the more scientific and not so poetic approach. Maybe you go ahead.
Well, I was just going to say, I think that there is something fundamentally romantic, capital R, in the idea of evolution. And what I mean by that, the romantic poets and writers and philosophers were all very, I think, one of their themes was the interconnectedness of the natural world and the interconnectedness of people, in that, the way in which you are kind of all through your sensory experience, one with nature and so on. And so, Lamarck was also the person who suggested that human beings have descended from other primates, earlier primates, and that people are kind of animals like other animals, having descended from earlier primates. Darwin then picked up that idea, citing Lamarck. So that, if that's not a connection of humans into the natural world, I don't know what would be. So I think there is a kind of basic romantic idea in evolutionary theory, that interconnectedness, dynamic interconnectedness and oneness of humans with the natural world. And I'm always telling my students, and I teach a history of science, scientific revolution, kind of early modern science lecture course at Stanford. And I'm always telling them that the biggest kind of scientific ideas come out of literary traditions. That's true in the 17th century also, and we have it here with Romanticism.
Well, then we can go to an even bigger issue, because to me there's a very strong similarity between what you wrote about in biology and what goes on in physics. Because in physics, people have this whole big theory, which is basically deterministic about the start of the universe. And that's the basic scientific idea. There is no free will. It's all determined. And I find it very ironic that shares that choice for determinism with Calvinism, so that you've got this divine God, and that is the source of all determinism, and then you have either the Big Bang or whatever you want to focus on as the source of all determinism since then. But there is no explanation, just like there's no explanation for a lot of things in biology when you have that idea. There's no explanation for anti-entropic experience in the deterministic thing, because if it's all moving towards entropy, this deterministic thing, where do the bubbles come in? We know they're just bubbles. But where are the bubbles of life? And we have a really big bubble on our planet. Where do they come from? And your idea, or at least Lamarck's idea about this, that it could be all these individual minds doing something, is much more in line. I mean, that's the only thing that we know of that causes anti-entropic behavior.
Right.
Is individual minds. Even ants do it. When you see an anthill, you know that it wasn't created by entropy. You know it was created by some intentional action. Of course, it's against that other theory to assign anything other than human beings any kind of agency either.
Right.
Right. So, but to spread it all out and say, hey, This is the anti-entropic thing. You don't have to, there's probably no way that we can come to a conclusion about that. But the fact that that's eliminated as a possibility seems highly unlikely. It's the only thing we have evidence for.
Yeah, beautifully put. I think that's really interesting. I mean, I do think that determinists, sort of modern scientific determinists, and maybe in physics, and I'll also say, I think neo-Darwinists, people who kind of regard living beings as just genetically programmed machines that are acted upon by natural selection, that these are the heirs to the argument from design. They're actually, it's a theology in the first instance. The idea of design is that was established in the 17th century. It was a theological idea, the evidence of a rational designer in nature. And so many of the people now, like Richard Dawkins, for example, who, I think he's an atheist famously, but I think he really is the heir, in his model of what the natural world is, what living beings are. He actually is the heir to a theological, deterministic, design-oriented. It originated in that. His ideas originated in that moment. So there's a kind of reversal. I think that's what you're describing there, right?
He'd probably be just as disappointed to find that out as a eugenicist would be to find out that a lot of his genes are from Africa.
Yeah. Right.
So. I find it I've always found it fascinating that we take agency and put it into genes. Why do the genes want anything? Do you know what I mean? What do the genes want? Why? I can understand they're a big part of what the machine is about that we use, but I don't quite understand what the genes want. The genes want to reproduce themselves. That's the idea, but why would they?
Well, and there is a sort of, when I said it's an extremist position, the idea that organisms are passive, and people actually sort of slide, often slid from the idea that they're passive in the evolutionary process to the idea that they're just passive, behaviorally passive, that they're just sort of behaving as they're programmed to behave, And it seems like that's an extremist position, and it's really a contortionist position, because you see, as Lamarck said, you see all around you evidence of living beings behaving in ways that are unpredictable and that look like purposeful, and so in order to say all of that is a figment seems really, in some way, anti-empirical and rather, contortionist.
Like say, you don't have to come to the conclusion that that's it, but you should certainly at least say that's certainly possible.
Yeah.
Because, like I said, there's a lot of evidence. Now I think of, even if the whole universe is moving entropically, or the galaxy is, and most of it isn't alive, we do have this bubble, and it has to be explained. And it's what our life is. So it needs to be, if we want to be scientific, that should be explained, and it doesn't have to follow the same explanation.
It's funny that you say it's a bubble, because we've been seeing these images of Earth now from Artemis II, and so really it looks like a bubble.
It looks like a bubble. Yeah, exactly. So let's talk a little bit about the personal stuff that you included about Lamarck, because it was a very interesting life that he led from a large point of view, and also it reveals, the awfulness of that time in terms of losing one wife after another to childbirth. And I always think when people are anti-scientific now, there seems to be another trend going on, to be anti-scientific.
There does.
And you say, oh, wait a minute, if you just went back 100 years, we lost so many children and so many young women to this problem. You have to have at least some kind of tenderness in your heart for science to have solved that problem. It's such a big issue.
Yeah, who would have thought, right?
Yeah.
We would arrive at that.
Yeah. Anyway, so tell a little bit of us. I'm from one of 12 children, so you didn't quite get to there. Yeah.
Wow.
But
where are you in the lineup?
I'm fourth.
Okay. Yeah, he was the last one.
Unfortunately, the theory about birth order isn't big enough to cover families that big.
Yeah.
They can't explain me.
Well, he did have this very, very kind of tumultuous life with, these 8 children. 4 of them, he outlived not only 3 wives, but 4 of his 8 children. But 2 of his daughters remained with him until he died and helped him. In the last decade of his life, he was blind and very frail, and they stayed with him. And one of them in particular, I think, probably wrote much of his last book, or wrote it with him, was at least a co-author. And it is an extra. I do think that when he talks about how animals respond to their environment, in creative ways. I can't help but see his own life in those terms. He starts off, he wants to be a soldier, then he's not a soldier. Okay, botany, then he can't be a botanist. Okay, zoology. And in each time, there's a kind of creative adaptation that takes place.
Yeah, it's interesting that, for example, that his two enemies, but couldn't get rid of them, but assigned him to the professor of insect and worms.
Right.
To all enemies in the world, you just watch out for what you do to a smart person.
Right.
Because you set him up for, you just can't stop a man who thinks like that.
And it's true, the enormity of the theory that he derived from looking at these tiniest and simplest organisms, because he was ultimately an invertebrate zoologist, and he got this whole theory from that. At the same time, he talked about all forms of life in the context of invertebrate zoology.
So talk a little bit about polyps and coral reefs. You mentioned it in your thing. That one of the things how did he observe this? But observed that they could reproduce out of almost any part of their body and make another one and stuff like that.
Oh, he was drawing on Tremblay, you mean with the hydra, the freshwater hydra.
Yeah.
Those were very famous experiments that this Swiss naturalist had performed, showing that you can chop them up in lots of little pieces and you get, and he made, actually the word hydra came from this because he could make many heads, right? Like he would cut them kind of lengthwise like this and not all the way down, and they would grow separate heads, right? And he made more and more heads on these.
I'm glad we can't do that.
Well, you could do it with a hydra, but not with a,
No, I mean, yeah.
not with a person.
Human beings, it wouldn't go down very well.
Yeah. So, I mean, it's true that, I think it's true that the organisms that Lamarck was interested in were indeed, they do indeed display quite magical powers or quite extraordinary powers of generation, which is what he then became interested in. But the idea also that there are mountain ranges and islands and continents, or coastlines that are shaped by these tiny, tiny, tiny little animals, I think also became a central idea for him.
I think it's a great image, too, for all of us in any culture or civilization that we do, is the coral reefs are there, and we're destroying them or hurting them a little bit. But if we want to build something on top of a coral reef, you don't completely smash it and start over again. That's not the way it works. You always have to build on what's already there.
Right.
And it seems like we have a tendency when we don't like something in some other civilization to smash it. Yeah. It doesn't seem to make any sense, first, it never works, but second, it doesn't seem very scientific either. So his children, his sons seem to have, just tell the story about, I think it was Andre, the one that went off to sea and everything. He had as wild a movement around as his father did.
Yeah, he had one child who was, one son who was absolutely bent on going to sea, and he, ran away at age 12 on a slave ship, I think. I'm pretty sure it was a slaving ship as a cabin boy, and disappeared for a number of years, and then they managed to find him and get him back to Paris, and Lamarck tried to get him to, be serious and study math, and he did that for a very short time, and then he went off again. So that's one of his children. He had another child who was a son who was very hard of hearing, and he again, trying to figure out creative responses to environmental constraints. What do I do with this very deaf son? And he thought, well, maybe he could be a painter and could paint wallpaper. Be a wallpaper artist. And so he found a training for him to do that. And one of his sons is the source of the family's, Auguste, from whom we know a lot about his life, because Auguste wrote one of the letters that informed Cuvier's so-called eulogy, as did the two of his daughters. Anyway, Auguste was the source of the family's posterity. He became very successful engineer and had several children, and those children had children. And in fact, this past summer, I met Lamarck's great-great-great-great-granddaughter by that line of descent, and that was incredible. That was an incredible experience. She, I wanted to see actually, I showed you the portrait of Lamarck that was painted during his lifetime, very lovely portrait, which has been in the family ever since it was painted, and I wanted to see that, and so I managed to track her down through her brother, who had, through the name, and then she invited me to her house to see the portrait, and she showed me some other books and papers that she had, and at one point, I was talking with her, and she said, "Oh, I have something you might be interested in." And she went rushing over to her front door, where there was a bin of umbrellas, and she pulled out a sword. And she said, "This is his sword from the Legion of Honor." And it was indeed his ceremonial sword. So
Sitting
right there in the bin of umbrellas.
in the umbrella bin, huh? In case you don't get an umbrella, at least you can go out armed against the rain.
Yeah.
So that brings me to another question.
Yeah.
In doing your research in this area, you moved around a lot. But you started during the pandemic, so
Right.
So it kind of some things got in the way, but you still went back to original sources, which
I did, yeah.
Yeah.
His papers are all in the library of the National Museum of Natural History, which is in the Garden of Plants in central Paris. And so, but that was closed during the pandemic. But the opening chapter, the kind of prologue, I guess, is about sort of, I was walking around in that garden actually with my daughter. It's a story of walking in there with my daughter. And I realized actually that the garden itself is really important to the story. This is the garden in which the first ideas of evolution began to emerge. Even before Lamarck, he was working on the basis of work that other people before him had done, but very much in France, in the kind of early to mid 18th century, and in this garden. And so I just realized that in fact I could do some research just by kind of walking around the garden and studying some of the trees that are there now were there then too, still alive. And so, yeah, so that kind of scene setting, I did that until the libraries and archives opened up again. And then, there's a sad part to I don't want to say sad, but there's a quite maddening, frustrating part to the story, which is that I was working on a really terrific project with some colleagues to make a web archive of Lamarck's papers. Actually, there was a web archive of these, a very useful one in France that had fallen into kind of disuse and needed to be rescued and built up. And so we were in the midst of doing that with a grant from the NEH, which would have been a really great resource for historians and for anyone interested in biology or the history of biology. And of course, we know what happened to the NEH. That grant, we lost that grant, so we're not doing that anymore.
So was Georges Cuvier the one who made the decision for the NEH?
Yeah,
somebody like him anyway.
The new Georges Cuvier is although, yeah. I think.
All right. Well, I'm sure that you have questions. Yes, great. Hang on. Can you hang on 1 second so I can? Yeah.
So I'm fascinated by a new kind of move in science. You must be interested too in terms of systems theory, which is a way of seeing things not so much from a reductionist standpoint, but from a standpoint of a kind of a more creative or almost romantic, almost like nature, because it is everything creates everything.
Yeah.
You have
Absolutely. I mean, I think that there is this kind of invincible persistence of people in each moment in the history of science to try and see things non-reductively. To try and I understand that there's a certain satisfaction in reductive explanations where you feel that you just have these few basic explanatory principles and you can conquer the world with those. But in fact, I mean, it's a much richer. I think non-reductive theories like the one that you're talking about, or like the extended evolutionary synthesis, which brings in animal cultures and behaviors and developmental processes and all. It's not just random genetic variation and natural selection. It's not only it's much more plausible, and it's also a much richer and more interesting picture of the world. So I do think that there's a kind of persistence in each age of the history of science of efforts to not reduce, to arrive at a more complex picture.
So coincidentally, on the way over, I was listening to Michael Pollan talk about his new book about consciousness.
Yes.
Basically, that potentially every living being has consciousness.
Yeah.
Do you think that this would be, no pun intended, an evolution of this creative agency idea? Do you think, I'm sure Lamarck wasn't thinking of that, or do you think that's something that just, is that an evolution of this creative agency idea, or would that be at odds, or could they be in concert? Like you're talking about, what are the different ideas? Because it seems to me, if what he was saying is that this evolution was purposeful, then is there consciousness that's driving this creative agency?
Well,
Question mark?
that's a fantastic question, and I think absolutely the idea that that all living beings have some kind of sentience or experience the world somehow, that is very much an idea of Lamarck, and not only Lamarck, but the people around him. So Erasmus Darwin, the people contemporary to him, let me say. Erasmus Darwin, I mentioned, Charles Darwin's grandfather, wrote poems about the love lives of plants and sex lives of plants. And the idea that plants have sex, that they're sexually reproducing organisms, also, is kind of coming out of this period and is part of what went into Lamarck's thinking. So, yes, the idea that all living beings share a kind of basic sentience or ability to experience or to respond, to kind of strive, those are all ideas very much in Lamarck's world and informing what he did. I'll just add one more detail, which is, I'm thinking of one particular poem by Erasmus Darwin about a love story between two plants, but he suggests that the first animals might have been insects that took off from, so he's looking at the anthers of a flower, and he imagines that maybe they took off and became insects at some point. And I think he saw maybe a dragonfly taking off from a flower, and it looked like a part of the plant. And then so in other words, he's imagining a kind of continuity between plant and animal life, and in emotional terms and sentimental terms, romantic terms. This is another example of why I say that some of the biggest, most important scientific ideas come out of literary writing.
Hi. You mentioned that Lamarck thought that humans might be part of the extermination of life.
Yeah.
So it seems that today human beings, let's say aggressive, bullying, warlike behavior might be what is likely to exterminate life on the planet. Do you think it's any possible that we could have learned behavior, that our own genetic offspring might learn to be more peaceable?
I have to hope so. As I think I mentioned, Lamarck suggested that human beings had descended from other primates, right? But the story that he tells of human evolution is not a beautiful story. He says basically that some primates came down out of the trees and began walking upright, and then the way they made themselves human was by being kind of ferocious and banishing the other primates to the poor corners of the earth and oppressing them. And so he has a worry about human nature for sure. But I have to hope. And I think that would be a lesson. Actually, at the last minute when I was finishing the book, I added a preface addressing the current war on science and education and learning and everything. And in that preface, I do say that I take a source of optimism from this Lamarckian idea of creative transformation. So I have to hope that yes, we can.
Well, I have another source of optimism from another area in philosophy, because the metaphysics of the situation I mentioned before about entropy and anti-entropic behavior, if you look at it and say, well, if the laws of physics have been going on for at least 13.6 billion years, and we still have anti-entropic bubbles going on, there must be some force which is anti-entropic, which is coexistent with the physical stuff. And it can also be physical, but it must also be something that's independent, or we wouldn't have anything anti-entropic anymore.
Right.
And therefore, you kind of say, when you go back to Aristotle's argument about first cause, which is again going back to the divine authority argument, that you can actually say, if you turn it around and say that might not be what's going on, that there's actually a continual present. And in the continual present, there are these pieces of matter that follow rules, and there are minds which play with them and make anti-entropic bubbles out of them, and that they're both going on the whole time. And so the answer would be that life is more like an eternal democracy than an autocracy.
Well, that would be.
But that would make them even more upset.
Yeah.
Because that's going right at the base. But I think that there's logic to that, scientific logic to it. Of course, as I said before, you can't prove those things, but I think that the logic actually leans further in that direction than it does towards anything else, until somebody can explain why we have anti-entropic behavior coming out of a deterministic, materialistic, reductionist approach to everything. There's no explanation for that. Anyway. Well, see, that's the question. Is the anti-entropic force God, one person, or is it all these minds? And
Certainly
it doesn't
not
make any
according to
difference.
Lamarck. Yeah,
No,
he was
and
definitely not.
The one thing that, the one argument in favor of that everybody's involved is that it's chaotic.
Yeah.
And that there are teeth on the whales, that they don't need them anymore. If you were just designing it, you wouldn't do that.
Right.
But if you were adapting over time, you'd have all kinds of remains of your stupid ideas, that
Right.
you had before.
Right.
So since we have a lot of stupid ideas out there, there's a lot of optimism for the
Okay.
the crowd,
I'll
the
take it.
we crowdsourced reality.
I'll
Anyway,
take
great book, a lot of fun. I'm sure a lot of people have already read it, but really, as I said, it doesn't happen very often that you can come back to somebody from a couple hundred years ago and say, rediscover this. You don't have to take 100% of what he said, but a lot of what he had to say in the basic thing might be a more interesting way of looking at something.
Oh, we didn't even come back to the clouds.
No, let's go back to the clouds.
Can I
Let's
tell
finish
the
with the
clouds
clouds.
story
Yes, tell the
quickly?
cloud story.
Okay. So when Lamarck first moved to Paris as a young student, he was living in a garret apartment under the eaves, and he told his kids that he could only see clouds and sky. And so he started studying the clouds, and he became the first person to taxonomize the cloud. He came up with categories of clouds, he named them, and he came up with a theory of meteorology that, according to the moon's influence on the atmosphere, and he set up the first government weather bureau, which was a participatory kind of citizen science. He had people all over France annotating notebooks. He taught them how to annotate their notebooks and then send him, at the end of the year, send him their notebooks. And he did that for 10 years, and then Napoleon shut him down. And I think it's interesting to consider why Napoleon shut him down, because you would think that Napoleon, of all people, who was the great modernizer and rationalizer, and who was, and also a general, you'd think he'd be interested in meteorology. But I think he didn't like the participatory aspect. That was, again, not his mode. And I also think it's interesting, the weather is famously unpredictable and irreducible. And that was not, also, I think, not his favored mode of science. And so, so I'm worried that not every anti-entropic force is
rational.
Is a
No.
good one.
Oh, no,
Yeah.
no, absolutely.
Yeah.
I find it ironic. Maybe we can end on irony, which is a good thing about life. Because he shut down the weather, then he didn't pay any attention to the weather when he went to Moscow. That didn't really work out for Napoleon after all, now did
You
it?
make a good point.
All right. Well, thank you very much, Jessica. This was just wonderful.
Thank you.
Thank you all for coming.